Welcome, everyone. Good morning. It is 7 o'clock in the UK on Wednesday, the 8th of December, which means it's relatively late for Sydney and Tokyo and Beijing, but it's very, very, very late over in the Pacific West Coast. That's the reason why we do our spread out schedule so that everyone can take part. So first up this morning, we've got Andreas. And he's going to talk to us about building a modern RTC test stack, which in itself is quite a feat. But first, I want to talk to you about the sponsors. I'm just going to get them up in front of me here. So our platinum sponsors, I should know these by now off the top of my head, but no, there are too many people to thank. So I need to make sure that I do thank all of them. So we've got Subspace, Daily, Element, and Mux. They're our platinum sponsors, and then our gold sponsors, Tulu, 100 Milliseconds, and Dite. They've got rooms in Matrix. Make sure you go and speak to them, and get to know what they have to offer. Silver sponsors, Lowway, Sangoma, Millicast, and WebRTC Ventures. And then we've got our community sponsors, Jambones, Telecurve, and Pion. And then our AV partners, of course, who actually make the physical event or virtual event, both of them, to happen. So that's PSP, Millicast, Broadcaster, Subspace, Element, Mux, and Meet Echo. Without all of these people and companies and projects, this event wouldn't happen. So please go and talk to them, reward them for their interest in supporting open source and supporting one of the only vendor neutral RTC events in the open source space, at least. So we're going to get on and listen to Andreas's talk, and then Andreas will be with me afterwards, and we'll have a little bit of a chat. So take it away, Andreas.
Thank you, Dan. So today I'm going to show you how to build a modern RTC test stack in the cloud. And what we are going to talk about is the motivation why I have been doing this over the last 18 months, and why there is a need to build, yet another test framework for telecoms. We are going to have a look at tool chains, like which kind of tools are actually available to test real-time communication on the internet. And we're going to have a deep dive into the architecture of how I actually approached building a test framework with a very much cloud-centric view. I'm going to show you also a bit about the infrastructure, like how I approached it and why, and some next steps, like where this framework is going to evolve. So I've been working in telecoms for 20 years, right? And telecoms historically were obsessive testers, right? So if we look at big Siemens soft switches, for instance, being rolled out in 1975, they have been developed for 5 years. Then there was a 2-year testing, and they did all the TÜV and ISO and whatnot certifications on that to really make sure that everything works, right? Now, the problem is that the evolution of these test tools being used here, they are in no relation to the feature velocity, how RTC products and RTC services are evolving, right? So there are great tools for agile web development out there, doing performance testing, doing functional testing, doing API testing, all of these kind of things, providing you ways to, to help your agile team, which is typically the kind of way how web tools are being developed. So they let you integrate all your tool chains into these continuous integration systems, continuous deployment systems, so that testing is being shifted very much to the left into the development process. Yeah. Now the problem is that that's not so much true for modern RTC development, right? There are only very few tools out there, and they are very scoped and very limited. And if you look at, developing a soft switch today, an internet telephony service, a video conference, or like a broadcasting service, you are actually left out with very little tools to use. And this is why quality is kind of lacking today in the development cycle of RTC products. Now, if you look at what you would actually test in a RTC development framework, then you're looking at three pillars. One is performance testing, the other one is functional testing, and the third one is security testing, right? So you want to make sure that your service, your video conference that you just implemented, can actually sustain, the number of participants that you are planning for. There's also the functional testing, of course, right? I mean, the products and services, they get more and more complex. And in the past, it was like, a phone call between A and B. Nowadays, it's like a video conference with screen sharing and, collaboration and all these kind of features that are being put on top of the typical audio conversation. And you just want to make sure that these things actually work. And from a security perspective, you really want to make sure that the thing that you now put on the internet is actually safe, like reasonably safe, let's put it that way. And these three things, they hold true for traditional SIP flows, and they also hold true for WebRTC scenarios, of course. And what you really want to do is, when you develop these kind of products, that you want to get insights into how your product actually works, like from a signaling perspective, and also how it feels to the user in terms of media insights. Is the video quality, the audio quality, the screen sharing quality, whatever you are actually, exchanging, is it actually on par with your expectations? And my own requirements have been there for 10 years. I was looking throughout my career of building soft switches, building video conferences, building RTC applications in general. I've been looking for proper tools that can actually give me these kind of insights, and I was just never really satisfied with what's there, right? And this is why I really started off trying to build these by myself, just trying to fix my own needs. And my own needs were actually to have like a scalable way to test things in a way that, I don't have to have like a big machine sitting there in a lab just waiting for the day where all the testing is done, and then all the people come in and want to do their testing, and then the big machine is just heavily overloaded, right? So you really want to scale with the number of tests that you're doing. The other thing is, when you look at testing, it needs to be accessible, because typically when you look at testing and testing in an agile environment, you don't have these focus QA testers. Rather than, you want to make sure that testing is going to be part of your development workflow, and every developer needs to be able to test their own code in an easy, accessible way. And the third thing is, it needs to be flexible, because you're testing various things with a framework, and you really don't want to switch tools for each individual test that you're doing. So my own need was really to say, okay, I want to have a framework where I test video conferences, I test audio calls, I test screen sharings, all these different kind of ways. I test it on a performance level, I test it on a functional level, I test it on a security level. So it's a bit of a far shot, actually, right, to try to solve these kind of things. But these at least were the requirements when I set off to try to implement a framework doing this. Now, what did I actually do, and where I am aiming for? I've just the other day worked with a client of mine who implemented a soft phone, a mobile soft phone. And we were together looking at ways to optimize the audio. Right? So they were using the Opus codec, and Opus is like known to be adaptive, and you can change bit rates on the fly. You can change the clock rate. You can change all of the parameters during a call. in theory at least, right? In practice, you really need to do this by yourself. The application needs to do this, right? So the promise is often you are going to use Opus and it's going to solve all of your issues. But if you look at what really happens under the hood is that you need to control this codec, right? And this is where we were looking into a test case where we were saying, when the mobile client is changing networks, right, from Wi-Fi to 4G to Edge, we want to actually adapt the bandwidth based on the environment, and we want to just reduce that. And the developers went off and did a great job of implementing it. And they were like, okay, it works, but actually, if you look at it, or if you hear or try to listen in, you don't hear a difference. And it turned out when we were starting a test, where we were just listening or waiting for an inbound call, then use the app to call into this framework and graphed the media statistics of that, we figured that actually the media doesn't change at all, right? It was just a flat line on the bottom right saying RTP received bytes per second. Until we really dig into that and figure that you actually need to do more with the codec in order to make it work. And if you make it work, then you can actually see in real time, for instance, your bandwidth, your received bytes per second on the test side, and how the audio or the bandwidth is actually adapting to your changes of the app. Right? So you really need to have a clear insight into what's actually happening, and that's often, particularly in telco systems, not so clear, right? And the main question is also, how are you going to approach these kind of tests? I mean, this was like a very specific one. The way I want to approach this, and I wanted to approach this, is that everybody can actually do these kind of tests. And this is why you need to, make a test very, very simple. Under the hood, there are a couple of tools we're going to look into, but just a spoiler, one is ZipP, right? And ZipP has 150 command line switches. And if you're not using that day by day, you can never remember this, and you're not even able to, create a test without, digging hours into the documentation. So the idea was really to abstract all of that, as I said, make it accessible and try to just have the very important parts in there to configure for you via a web user interface, or via an API, of course, because you really want to, automate things and want to integrate this into your continuous integration systems. And the other thing is, if things go wrong, you really want to have a clear idea what the problem of the test is, right? Because if all the tests are good, you're happy, I hope you're happy. But if something fails, then the first question is always, why did it fail? Did the system under test fail? Did the test itself fail? And you really want to have an insight into all your signaling, all your media, and you really want to look into the details, what happened with the test and in the test. And you want to have a clear insight and a clear, observability means to look into what's going on. So that was basically how I went out to build it from a requirements point of view. Now, the approach I took was really not to try to invent too much new things, rather than taking existing building blocks and put them into the year 2020 or 2021, right? You're going to deal with a couple of different components when you need to do the testing. And the obvious thing when people start testing is they are going to take an existing tool like ZipP, right? ZipP is there for over 15 years already, right? But if you look at that, I already said it's like 150 command line switches. You have an XML that you have to write yourself, all of the zip messages, all of the signaling. If you do one single thing wrong there, then the whole call is going to break, because you're going to, write down the exact signaling of this. There are other tools like ZipWishes, for instance, for a security testing point of view, right? To do, password cracking. There are fantastic tools like Zip User Agent, like PSZip, that you can actually control programmatically in order to start tests, right? Or to start calls, to wait for calls, to send audio, to record the audio for later preprocessing. Right? So these are the typical tools that people know, right? And the goal was really to take them and pack them into an accessible way of using it. From a media point of view, this is a tricky thing, because if you take scalability into account, then it gets very tricky very quickly, right? Because if you want to, simulate a large amount of video calls or even voice calls, then you're going to have a lot of traffic, and you're not going to create this traffic each time individually, rather than taking an existing PCAP, like a network capture of a call, for instance, like 10 seconds of a particular codec, and you just want to play it out. And for this, TCP replay is a very nice tool. Right? So these were more like from a telephony point of view. When we look at RTC testing, we are mostly dealing with browsers. And for browser testing, you can actually use a headless Chromium and drive this and simulate a particular user. Right? So these are the traffic generation components that I was looking into and was trying to use. There is a second kind of components, which is edge components. And by edge components, I mean like the components facing your system under test. And for these, I'm working since, I don't know, 10, 15 years already with the two power horses of RTC, which is Chameleon and RTP engine. Chameleon is basically a zip proxy, right? And it's so flexible that you can do all kind of things with that, like header manipulations and whatever you want. You can really tinker with your signaling. So if you want to do like an exotic test saying what's going to happen if I put like an arbitrary header into my signaling, you don't want to patch zip or ZipP for that, right? You just want to inject that in a very simple script-driven way in Chameleon. Chameleon also helps you, to bridge between, IPv4, IPv6, UDP, TCP, TLS, SIP over WebSocket. You can do all kind of transformations with that without having to touch the traffic generation component, right? So it's really more like if you want, a session product controller. And the same goes for RTP engine for the media, right? So RTP engine allows you to extract all these media statistics via MQTT, for instance. So what you can do is in real time watch your media streams and watch how they are evolving, like how many packets per second are you sending, which kind of codecs are involved, how many one-way audio calls do you have, how many calls are on hold. So all these kind of metrics that you want to know. And besides that, it can do the normal RTP to SRTP crypto bridging, so your clients, your traffic generation components don't have to. And then there are capture components. Capture components are being used for gathering all the metrics that you need, like what's your traffic statistics, what's your headless Chrome doing, right? Like how do you get all the output that these tools are producing? How do you get this into like a central element in a central cloud, right? And for this, I'm using Pastesh, which is great, which has a lot of input modules, a lot of output modules, so you can mix and match and filter your input and send it off to somewhere else for later processing. And then there's Homer and Hepic for the signaling and media capturing, right? Because as I said, if something goes wrong, you really want to know what went wrong. You really want to know what's happened with your test calls, and you can actually look into that with these kind of tools. Now, if you put these tools together, it's fairly obvious nowadays, right, that you put them into a Docker container, right? Because you don't want to install all of these elements into onto your machines individually because of library mismatches and so on. So you just put them, all of them, in a container. Try to build a small system to have them interact together, and then send off the traffic to a system under test or receive traffic from a system under test. And you are going to have one container that can do so much. It can do, I don't know, like 50 concurrent calls, right? But if you're looking at simulating like a big system, you actually don't want to have 50 concurrent calls. You want to have like 5,000 concurrent calls or even more, right? Or you want to do, I don't know, simulate 100,000 PC hour call attempts if you want. And you just can't do this with one single Docker container. You can make the machine, the underlying machine, very big, but at some point you're going to hit limits, right? And this is where you want to scale them, and this is where orchestration comes in, where you actually need to drive a lot of individual containers. And this is where the typical off-the-shelf, open source components start failing, because there's just nothing out there that can actually do this. Telling 10 or 20 or 50 CP instances to deliver traffic is one thing, right? But what you also want to do is you want to aggregate the output of that. You want to, get it all together and want to display it in a proper way to the user, to the tester. And this is where aggregation then comes in, right? You're going to deal with a lot of data that comes in. And the way I try to address this is, again, looking at all these open source components and trying to glue them together with certain individual components that I developed. Learning a lot from that in a way how you actually deal with these big amounts of data that are going to be produced. So the way it's basically works is that you have a web interface or an API. And obviously, you need an application to work with the test, to start a test, for instance. And what I try to do is using MQTT as a message queuing protocol, as a control protocol, where you say, I want to start a test, I want to do like 5,000 concurrent cores, or I want to join with 50 browsers concurrently into a Jitsi Meet instance, right? So in that particular case, we're looking at cores, like a media core, for instance, and you're going to control your traffic generation agent, which would be PSIP in this particular case, with MQTT. So MQTT is going to, or there's like a JSON structure saying, okay, dear PSIP, you're going to start, and then you're going to call a particular number, and if the call is up, then you're going to, put it on hold after 5 seconds, unhold it, and check if the media is still there. Right? You also need to orchestrate on this individual container, like in an agent, your Camelio instance, right? Because PSIP is going to use Camelio as an outbound proxy, and Camelio is then sending the traffic off to your system under test. And Camelio is going to drive RTP engine. Why? Because we really want in real time all the MQTT statistics that are going to be produced. Because using RTCP statistics is one thing in PSIP, but sometimes you just want to have more insights, like how many packets per second, how many bytes per second. What about this one-way audio, two-way audio? What about the codecs that are being involved? So all these kind of statistics can be pulled from RTP engine. And naturally, since we're already using MQTT for the control of all these components, we're using MQTT to extract all the metrics out of this agent, right? So in a small test, it would be just one, but it could be 50, 100, or 1,000, right? And all of this comes together in a very small tool, like I call it zip from persistor, which is really just actually a burst script that is subscribing to a particular topic on MQTT. And depending on which kind of message is coming in, it writes status updates into a Postgres database, right? And it writes metrics into a CLogKey log aggregation system, which in turn stores all of that in ClickHouse, right? If the test is done, or if you are looking in real time at what's going on with the test, you really want to, show all the charts or the metrics that are going on. And in the beginning, I was using like a self-made chart.js based system, and it really sucked, right? If you want to pull all kind of data out of Postgres, potentially like in JSON format, you need to start parsing it, you need to start aggregating that, and then you need to, via WebSocket into your app, get all the data, graph it, and you have like a 12-hour-long call. You get like so much data points in, and it just is gonna break. And you really need a data scientist to say, okay, I need to start, aggregating the data down to like 5 minutes, 10 minutes, whatever, in order to just keep your browser alive, right? So for that, actually, I really switched to Grafana because this is like the standard charting, graphing engine, if you want. And you can take your dashboards and your individual charts that you have there and just embed it into your application so it really looks native, right? So if you look at like a clockwise flow through this test, then you create them, you start the test, you're going to generate your traffic, the metrics come back, and you're storing that, and then you're charting that on your application. Now, the nice thing about that, and this is what I said about flexibility, is what if you want to do WebRTC testing and not zip testing? The funny thing is that actually it looks pretty much the same, right? So the only things that change are certain tools in your agent, because obviously you're not going to use PRZip to, test WebRTC rather than Chrome or a headless Chromium instance. So what you're using for that is well-known tools that you use for web testing, and you can actually use Puppeteer, and Puppeteer can be used to be remote controlled from the application, and can in turn drive your Chromium with some custom JavaScript that you give it, saying you are going to simulate some browser clicks in order to join, for instance, a video conference or some WebRTC application. And once the web browser, the web application is being joined, you are going to establish, like your normal browser does, your WebRTC connections. And then you're going to pull all the statistics that Chrome is providing you with WebRTC internals, for instance, and send them back into like this central post-processing cloud. And this works very well using, for instance, PassDash to say, okay, you start Chromium. Chromium is going to, provide you all of the statistics, like how many participants, how many peer connections do I have? What's my media quality with this? Like, what's my bandwidth? What's my number of packets? What's my packet loss? You collect all of this with PassDash and send it over MQTT, like you do with RTP Engine and Camellia, back to your central system. And you can then handle it exactly the same way as with zip tests, by just graphing them in Grafana. The problem is that these metrics that you can pull out of these tests, they're going to be overwhelming, right? So I said before, in the beginning, I really naively tried to do it basically manually by myself, writing all of these things into a nice Postgres table, and then, trying to fetch them once per second. And what you're dealing with is, if you're starting with just one test, then the matrix that you're going to get out, they are kind of structured in a way that it's a JSON blob, right? And then you can, take it apart and take the individual objects, take the individual fields, and store the fields that you need in your Postgres database. Now, if you start extending your tests, then you are going to start extending your tools as well, and they are going to change in a way how they deliver your data. So the data will be completely different, and you are not going to I tried and failed. So you really do not want to start picking apart all this different data in your backend and store it into individual tables, because you're just going to get lost. Now, what you can do instead is you can leverage the tools that you already have at hand in this framework, like ClickHouse as a database, CLoki as a very nice interface to access the data, and Grafana to display the data, to just go and say, okay, what do I actually have in terms of metrics in my database? Like you're going to look into, okay, I'm having a raw JSON blob. So how does it actually look in a structured way, right? So we are going to deal with, in that particular case, with particular codecs. And you can see that in the very bottom, there's metrics bytes per second, right? Now, what you can do with CLoki, which is really an open source re-implementation of Grafana Loki for ClickHouse, you can just, in a very simple, like in that case, 3 lines query, pull the data out and graph it directly in Grafana, instead of having to write like a 50 lines SQL query that I actually ended up with in the beginning. Yeah. So from an architectural point of view, I had a very clear idea how I wanted to approach this. Over the last 20 years, I was like the bare metal guy, right? So everything I built was really on physical machines, and cloud was really just, using an EC2 image on Amazon, and that was it essentially. So I really took this opportunity just for, me personally, to say I really want to learn about all the tools that are actually out there that you can actually use. On one hand, just to get an idea of what's available and how like a real cloud application would look, right? So that's one thing. And the other thing is, since I was doing this as a one-man show, I really didn't want to waste time, setting up and maintaining databases, right? Or setting up and maintaining a message queue, or setting up and maintaining, I don't know, a Kubernetes instance, or whatever you would need for that. So I was really trying to focus using or looking at AWS and looking at the tools that are available. And for that, you really have a ton of components there, from network and compute for things that you actually can't use as a service, up to containers. Like in AWS, you have ECS Fargate, for instance, to put a web application there, and it's just going to auto scale automatically based on some CPU and memory thresholds. And that's just nice, right? And if you deploy a new version, then it's going to start this version, going to redirect all the traffic to it, and then it's going to tear down the old one. And you just don't have to care about, this orchestration of how do I seamlessly update software. And you can use these tools for a lot of things like monitoring, logging, configs and secrets management, certificates, and so on. Of course, you can use Let's Encrypt, and that's probably something that you want to do at some point. But on the other hand, you can just use their certificate manager that's there and just don't deal with these things. Now, next steps. So what are we going to look at in I don't know, half a year or a year? So one main thing is really to launch this, right? So I've been working on this framework for about a year, seriously, and half a year before that, trying to tinker. And it's been in private beta for a year, and I got a lot of feedback, like what works, what doesn't work, and it was really great. And we're now approaching the point where we can actually release this to the general public. And the other thing is, as I said, I was using AWS because I just wanted to get a grasp of how or what's available, how does it work. And one main learning point is AWS is convenient, but it's hell expensive, right? It's if you just look at like a production system and a development system, it's going to cost you a couple of €1,000 to run it month by month, right? And it's just insane in a way that if you can do these things yourself, you're better off doing certain things yourself, because it's gonna cost you a lot, unless of course your time is better spent with other things, like bringing the application forward. So it's really like a trade-off what you want to do, but as soon as you can, it's actually better to do more of the things by yourself or trying to offboard it to different services. And the other thing is, so there's a pre-defined set of tests that you can do at the moment. And people in the private beta were expressing needs for different kind of tests. So one of the main things is really that users are supposed to create their own scenarios. And one thing is really to create your CP scenarios by from scratch and with the help of PCAP files. I'm going to show you in the next slide, and the last one actually, in a minute. And the other thing is that you can actually use machine learning models to auto-create variations of that, because for every successful test case you're looking at, there are at least a dozen of failed scenarios. And one of the reasons why the test coverage of telco systems is so bad is that it's so tedious to create all these tests manually, right? So the actual idea is really to say, you're going to record a particular phone call, for instance, that you want to test live, and then let certain machine learning models try to find variations of that, like what happens if the other side is actually PC is not picking up, if the caller is hanging up before the call party is able to pick up the call. And the way it's going to look like very roughly is, for instance, that you can, with Homer or HEPIC, capture network traffic and then analyze the PCAP, and then auto generate, for instance, a CP scenario out of that. And then you get like the building blocks saying, okay, I've seen on the network an invite, and I've seen a 100 coming back, and a 180, and a 200, and then the client send an ACK. So this is how it looks like. This is how I can generalize it for you in terms of templates. And then you can actually edit these things very easily, saying, I want to add a header here, or I want to change a certain behavior there. I want to not have a 180 but a 183, so I can actually edit it very easily without having to create it from scratch. Right. So this is basically one of the main goals to approach next. Right. So that was it. I hope you got a good insight into how my approach of building like a modern RTC test framework looks like. And if this is helpful or seems helpful to you, just join the private beta on one hand, or if you have particular questions to certain elements that I was using and you want to know more about it and want to know how I was using that, just don't be shy to ping me on Twitter or by email anytime.
Thank you, Andreas. So I'm going to bring in real-time Andreas right now. So hello, good morning, Andreas. How are you?
I'm good, thank you. Thanks for having me.
Good. So we've got a question from the audience. At which stage of development do you recommend testing? Do you tailor your test based on the stage of development or like the end goal of the whole project?
Well, I mean, in the past, basically there were their own QA teams that did the testing pretty much at the end, right? But with this agile transformation and continuous integration, continuous development, testing moves more and more to the left, right? So there's no dedicated test teams, but developers do the testing, and obviously it's advised to do the testing as soon as you can, right? Because it's better, right? I mean, there's test-driven development even where you can, write the tests before you even do some code, right? That would be the ideal scenario if you ask me.
Right.
But then again, it really is up to, creating the tests is so time-consuming that, we need tools to support with that. Otherwise, you develop for 2 hours for a feature, and the whole test around that takes you 2 days, and that somehow needs to be solved.
Yeah, and then in 2 weeks' time, you've already moved on to something, and you need to go change that test again and again and again. You need to get those test creation times down to 10 minutes, right? Half an hour to really get good, to get good reward on it. Well, thank you very much for the session. It was truly remarkable to watch it. I've been following what you've been doing for the past couple of years, so it's interesting. It's great to have another kind of company within that space pushing things forward. So thank you very much, and everyone, we'll be back for another session in just a moment, so stay tuned.